Okay, so these are the last two problems I did as part of this midterm reassessment. The new one is right here. I labeled it midterm 3. So I'm going to try to make it a little bit bigger. Zoom in here. The only thing relevant is whatever's not scratched out, I guess. So the mistake that I made when I actually took the exam was I pretty much used the wrong formula. I used the change of uh, magnetic field, which would have worked if we were measuring the difference from point A to point B, or a certain length here. Like if, say, the proton was traveling, you want to know after a certain amount of time it's going to be at point B. So from point B to point A, whatever. So I just used the wrong one. So we have a formula here that's going to work a lot better. So really the only thing we have to do is take QV crossed with R hat over R squared. So what we need to do is find this R value. First of all, the magnitude of R. So R is going to be the distance between the proton and our observation location, I guess you can call it. So there's two ways to do it. You can either do you can use trig to get 0.0078, or you can use a squared plus b squared equals c squared. So either way, you get the same answer. So that is, I don't know why I put a vector sign over that, because it's not a vector. It's a magnitude. So once we have that, I pretty much just filled in our values here. I wrote the formula and I filled in, step by step. That's our Q value. It's just uh, the charge of a proton, and then the velocity vector that the proton is traveling in, which is obviously the negative y direction, and my magnitude of r, and then r hat. So from there, I just pretty much filled in these values into the formula as simple as possible. I didn't get a numerical value. I know you're trying to fly through these things, and so am I. So I really didn't punch this stuff into the calculator. But looking at the problem, it should be, let's see what direction it should be. QV cross R. R is, let's see, on the plane. It should be in the positive z direction, if I'm not mistaken. Right hand rule. So, yeah, that's about it.